Welcome to the Copperfield Electric Podcast.
It's great to be back.
I fell down a bit of a rabbit hole this morning. I was scrolling through one of those home renovation forums, the ones.
Oh, I know them well. Let me guess. People agonizing over paint colors.
Exactly. Which shade of off-white is best for a north-facing room? Or should my kitchen island have a waterfall edge? It's all about the aesthetics, the stuff for the big Instagram reveal.
Well, of course. That's the surface layer. It's what you see every day.
But here's the thing. I have never, and I mean not once, seen someone post a picture of a bare wooden stud with like a gray wire stapled to it and say, check out this masterpiece.
Which is really a shame, isn't it?
Yeah.
Because that gray wire, that's the nervous system of your entire house. You can have the most beautiful marble countertops, but if that wiring is wrong...
Your kitchen's just a really expensive dark room.
A dark room, or worse.
Or a fire hazard.
Exactly. Or fire hazard.
So today we're going to do something a little different. We are peeling back the drywall. We're going to ignore the paint colors and do a deep dive into that invisible skeleton. We're talking about electrical rough-in for new construction.
It's a term that gets thrown around on job sites, but I don't think most homeowners really get what's at stake.
And to guide us, we're looking at some fantastic source material. We're pulling a lot from a new technical guide. Just came out in February 2026. It's called Foundations of Power by Renee Hernandez.
Which is a great read. Hernandez does a really good job of bridging that gap between, the official code and just common sense.
And to pair with that theory, we're also looking at the service philosophy of Copperfield Electric. They're a team right here in Orange County, and this is what they live and breathe every single day.
It's a perfect pairing, really. You get the textbook version from Hernandez and then the muddy boots reality from Copperfield of what actually happens on a job site in, say, Irvine or Anaheim.
So the mission for this deep dive is, well, it's simple. We want to show you why the ugliest phase of building a house, all that wood and dust, is actually the most important moment for your home's future. It's safety, it's efficiency, everything.
It's the point of no return. You have to get it right.
Okay, so let's start with that term, rough in. It sounds kind of aggressive, doesn't it? What does it actually mean?
So technically, the rough-in phase is what happens right after the framing goes up. You've got the wooden skeleton of the house. The roof is probably on, but the walls, they're completely open.
So no insulation yet, no drywall.
Nothing. You can stand in what will be the kitchen and see right through the studs into the bedroom. This is the window of time when the electricians come in to install all the boxes and run all the cables through the studs.
But, and I think this is a key point, we're not actually installing the light switches or the outlets themselves.
No, absolutely not. That's a huge misconception. If you walk onto a site during rough-in, you can't plug anything in. There are no faceplates. It's just wires sticking out of boxes. It's pure infrastructure.
Hernandez calls this the open wall opportunity. I love that phrase. It really implies there's a clock ticking.
There is a very limited window.
Yeah.
I mean, think about it. This is the only time in the life of the building you have total easy access to those wall cavities. You can run a wire from the top floor to the basement in, 10 minutes?
Because you're not fighting anything.
You're not fighting anything.
Yeah.
Once that drywall is up, that same little job becomes a 2-day project.
Yeah.
You're cutting holes, fishing wires through, blindly patching, repainting. It's a nightmare.
So the drywall basically seals the deal. What's in there is in there.
It's all about permanence and the cost of correction. Hernandez makes a great point here. If you realize you forgot an outlet during rough-in, adding it costs maybe $50.
Okay.
If you realize it after the walls are painted, you're talking hundreds, maybe even thousands, because you have to undo all that finished work.
Okay, so I want to visualize this.
Yeah.
If we're walking through a framed out house, what are the actual guts we're seeing? What are we putting in the walls?
It really comes down to 3 main components, and they seem simple, but the details are where everything can go wrong. First, you've got the electrical boxes.
The little blue or gray plastic rectangles you see nailed to the studs.
Exactly. And to most people, they're just holders. But there's a detail in the Copperfield electric standards that really jumped out at me. They call it depth calibration.
Depth calibration. That sounds way too technical for a simple plastic box.
It sounds fancy, but it's just practical. The electrician has to mount that box so it sticks out from the stud just enough to be perfectly flush with the drywall that isn't there yet.
Ah, so they have to predict the future thickness of the wall.
Precisely. And this is a classic DIY mistake. Your standard drywall is half an inch thick. But what if it's a kitchen wall? You might have a tile backsplash, and now your wall is maybe an inch thick.
And if you guess wrong, what happens?
Well, if the box is set too deep, your outlet sinks into the wall. When you go to plug something in, the plug feels loose. It might even fall out.
That's just annoying.
It's annoying, yes, but it's also a hazard. A loose connection creates heat, and heat can lead to fire. Plus, it breaks the fire-rated seal of the drywall.
And if it sticks out too far?
Then you get an ugly gap between the wall and the faceplate. It just looks shoddy. And again, fixing it later is a huge pain. You have to get that depth right from the start.
That takes some real foresight. Okay, so that's component one. What's number two? The cables.
The cables.
Yeah.
The nervous system. This is that Romex wire you see snaking through all the studs.
Is there strategy for how that's run? Or is it just, the shortest path from A to B?
Oh, it is definitely not the shortest path. There are very strict codes about how you support the wire. You can't just let it dangle. It has to be stapled to the stud within about 8 inches of the box, and then every few feet after that.
Why staples? What's the risk if it's just hanging in there?
Vibration, houses settle, doors slam. Over years, a loose wire can rub against the wood stud, and that friction can wear away the plastic insulation. And if bare copper touches wood,
Zap.
zap. And potentially a fire.
Wow. Okay, I never would have thought about the long-term friction aspect.
And then there's something called a nail plate. This is so important. If a wire has to pass through a hole drilled in a stud, and that hole is too close to the edge.
Where someone might drive a drywall screw later on.
Exactly. The electrician has to hammer a little steel plate over that spot. It protects the wire. So when the drywall installer comes in with their screw gun, they hit that steel plate instead of piercing the live wire.
That's a tiny detail that could prevent a disaster.
It's a huge deal. A Nix wire might trip the breaker immediately. That's the best case scenario. Worst case, it creates a weak spot that just heats up slowly over years until it finally fails inside your wall.
That is a terrifying thought. Okay, so that brings us to component number 3, and this is the one that felt the most technical to me, wire gauge.
Yes, this is absolutely critical. This is where the real expertise comes in.
Okay, so explain this simply. In my mind, a wire is a wire. It carries electricity. Why does the thickness matter so much?
Okay, think of it like plumbing. If you want to fill a swimming pool, you can't use a drinking straw, right? You need a big fire hose. Electricity is the same. An appliance that uses a lot of power, like an oven or an air conditioner, needs a lot of electrical current.
So it needs a fire hose wire, a thicker wire.
Correct. And we measure that thickness in gauge. But here's the part that trips everyone up. The smaller the gauge number, the thicker the wire.
That's so backwards.
It's completely counterintuitive.
Yeah.
So, like, a 14-gauge wire is pretty standard for lighting circuits.
Yeah.
But a 10-gauge wire is much thicker, and you'd use that for something like a water heater. If you use that skinny 14-gauge wire for a high-power appliance...
It's the drinking straw problem.
Exactly. You're forcing too much current through a space that's too small. That creates friction, which creates heat. The wire gets hot, the insulation melts, and you have a major fire risk inside your wall. Hernandez is really clear on this. Using the wrong wire gauge is a leading cause of electrical fires.
And you'd have no idea it's happening. It's completely hidden.
Right. Which is why the rough-in is the one and only time to get this right.
This all leads perfectly to what I thought was the biggest aha moment in the Copperfield electric materials. We've talked about safety, but what about future-proofing?
This is where you go from just building a house to building a smart investment.
Because the rough-in isn't just for the things you own today, it's for the things you're going to own 5 or 10 years from now.
Exactly. The electrical needs of a modern home have exploded. Think about home offices, smart home tech.
And the really big one, electric vehicles.
That's the game changer. Both our sources, Hernandez and Copperfield, they hammer this point home. If you are building a new house today and you do not run a 240-volt circuit to the garage for an EV charger, you are making a huge financial mistake.
Even if I don't own an EV.
Even if you swear you'll never own one, because the person who buys your house from you probably will. It's about resale value. But let's just talk about the cost.
Yeah, laid out for me.
Okay, during the rough-in, the walls are open. The electrician can run that heavy-duty wire to the garage in maybe an hour. The total cost might be, what, $300 to $500?
Okay, that's manageable. And if I wait until after the house is finished?
Now it's a massive project. You're cutting holes in the ceiling, maybe trenching outside. Then you have to patch and paint everything.
What?
You're easily looking at $2,000 to $4,000.
So you're spending thousands later to save a few hundred now? That's a bad trade.
It's just bad math. And it's not just EV chargers. It's induction cooktops, heat pumps. The world is electrifying. You want to build in that capacity from the start.
It's about having the option, right? You want the option to upgrade later without having to tear your house apart to do it.
Exactly. You want empty slots in your main electrical panel. Empty slots are a beautiful thing. They represent future potential.
Okay, so we've done it all. Our boxes are set right. Our wires are stapled and protected. We've planned for our future Tesla, but we can't close up the walls yet. We have to face the final boss.
The inspector.
You know, inspectors get such a bad rap. People see them as just these bureaucratic hurdles.
And on a job site, you'll hear the grumbling, for sure. But the inspector is your best friend. They're the only person in the entire process whose only job is to make sure your house doesn't burn down. They have no financial stake in cutting corners.
So what are they looking for in that rough-in inspection?
They're walking the whole site. They're checking for those nail plates. They're tugging on wires to make sure they're secured properly. They're looking inside the boxes to make sure the grounding connections are solid.
And if you fail that inspection,
Everything stops. The drywall delivery gets sent back. Your timeline is shot. You have to fix every single issue and then wait for them to come back for a reinspection.
what's the most common mistake that makes people fail?
Box fill. That's a big one.
Meaning?
Meaning you've tried to cram too many wires into a single electrical box. There are strict mathematical limits on that because too many wires in a small space generate too much heat. The inspector will literally count the wires.
Listening to all of this, the calibration, the gauges, the box fill math, this does not sound like a weekend DIY project.
Absolutely not. Look, I'm all for people painting their own walls or even laying tile. But electrical work, the risk is just too high. If you mess up a paint job, it looks bad. If you mess up the wiring, it's a catastrophe waiting to happen.
Which brings us to the licensed advantage. Looking at the Copperfield electric site, they make a big point of being licensed, bonded, and insured. Their license is #1094740.
And that license number is so important. In California, if you hire an unlicensed person and something goes wrong, your homeowner's insurance might not cover you.
Seriously.
Oh, yeah.
Yeah.
Using a properly licensed company like Copperfield creates a chain of accountability. It protects you.
And they seem to be a family-owned business based right in Tustin, not some giant faceless company.
Which I think matters. For a local family-owned business, their reputation in the community is everything. They can't just disappear. They live here.
And they serve a really specific area, too. Orange County, places like Irvine, Santa Ana, Costa Mesa, Newport Beach.
And that local knowledge is more important than people realize.
How so? Isn't the electrical code the same everywhere?
There's a national code, yes. But every city, every municipality has its own little quirks and amendments. The inspector in Laguna Beach might care about one thing, while the inspector in Mission Viejo focuses on something else.
So having a local electrician who knows the individual inspectors and their pet peeves is actually a huge advantage.
It's a massive advantage. It just smooths out the whole process. They know the landscape.
They also mentioned specializing in ADUs, accessory dwelling units, which is a huge deal in Southern California right now.
It is, and ADUs are complex. You're basically adding a small house onto your property's electrical system. That requires some serious calculations.
I really like this quote from their philosophy. We will only diagnose a problem if it truly exists.
That's the honest electrician promise, isn't it? We've all had that fear of a technician coming in and inventing problems to pad the bill.
Yeah, your whole electrical mainframe is shot. That'll be $5,000.
Right. This approach builds long-term trust. It says they'd rather do an honest job and have you as a customer for life than make a quick buck and burn a bridge.
And they're available 24/7.
That's non-negotiable in this field. An electrical emergency doesn't wait for business hours. If something is sparking at 3 in the morning, you need someone who will actually answer the phone.
And all their technicians are background checked.
Which is just basic peace of mind. You're letting these people into your home. You need to know they're trustworthy, vetted professionals.
So if we zoom out from all of this, we started by talking about wires and studs, but really the whole conversation has been about one thing.
Foresight.
Foresight, exactly. So what's the one key takeaway you want someone to have after this?
I want you to look at that messy construction phase, the rough-in, not as something to rush through, but as the moment you're building your home's intelligence. A good rough-in is invisible when it's done, sure, but it's the difference between a home that works for you and one that constantly works against you.
Get the bones right and the rest will fall.
That's it. And if you're in Orange County, whether you're building a new home or just adding that EV charger in Tustin, it seems like Having a team like Copperfield Electric is how you make sure those bones are rock
Yeah,
solid.
they've got the local expertise, that family-owned accountability, and they know the difference between all those wire gauges so you don't have to.
And that is a service worth paying for.
So here's a final thought. The next time you walk into a room and flip on a light switch, just for a second, pause. Think about that invisible map of wires inside the wall. The planning, the staples, the little steel plates. It all had to be perfect for that simple, boring moment to happen safely.
It's a modern miracle we take for granted every single day.
Until it doesn't work. Thanks for doing this deep dive.
My pleasure.
We'll see you next time.